Good morning, I'm Cameron from Higher Development, and today I'd like to talk to you about our Jira plugin, RiskEvader. My team and I are a group of students studying computer science at the University of Wollongong. With this project, we aimed to implement machine learning and artificial intelligence into agile development through Atlassian's Jira Service Desk platform. The core challenge is, how can we predict the risk of change in IT projects? And how can we automate it for greater accuracy and time efficiency? A change in an IT project could be a fix for a bug, a new feature, or even just a basic update. Currently, it falls to the project manager to manually review these changes and approve based on human analysis. This can be time-consuming and prone to human error. The main value in automating this is more time for IT teams to focus on core business functions and providing greater insights into the risks associated with change. RiskEvader achieves this by automatically classifying change requests by level of risk. Then, low-level risks can be automatically approved, and high risks can be further reviewed with a better understanding of potential problems. This project is designed for Jira Service Desk. Jira Service Desk is an agile tool developed by Atlassian, and RiskEvader fits into multiple aspects of Jira to provide risk predictions, insight visuals, and configuration options. Some of RiskEvader's main features include a glance add-on for quick insights into the risk rating of an issue, a reports page with further insights into risk distributions in a project, a configuration page which allows users to manage automated alerts and settings, and a dashboard which provides greater control and transparency of the machine learning predictions being made for the project.
Hi everyone, I'm Jin Wang and my English name is Esther, and I'm a member of Higher Development Groups, and today I will introduce the glance panel of our product. When you enter the RiskEvader, you will immediately see the two panels. One on the left is the request description uploaded by the user, and on the right is the result of the risk assessment. First, we can see from the glance panel is a drop-down box on the right-hand side, and it includes the three risk evaluations. Green means low risk, yellow for medium risk, and red means high risk. And the drop-down box allows the user to change and override the result given by the RiskEvader. The RiskEvader will study from the user's change and improve to the next analysis. Also, the color will immediately change when the level of risk is changed. In the second part of glance panel, we will see a spider graph show the weight and various features, and user can know which features are most important in the change. The spider graph makes data visible for the user, so when the user changes risk evaluation, the color of spider graph also changes immediately. Since some of the features are too long to describe, so we have labeled all the features with a letter. In the third part of glance panel, a table shows the 5 most important of all effect features and giving a description and weight and value of these 5 features, and a full list of the features were displayed in the RiskEvader report. Therefore, the user can check and understand why the features are important.
Hi everyone, welcome to RiskEvader. I am Vincent and I will show you our reports page. In this page you can see the risk count and the level of risk. At the moment there is 9 risks that are labeled low. You can also choose a feature in this below, and you can choose which project you wanted to, which features you wanted to look at. At the moment, it is OPD2. You can choose anything you like from the list, and there will be weight and value for it. At the moment, because some of the data are not yet that loaded, so the weight and values are a bit random. We will fix that up soon enough, and yeah, these are the overall report from this. And yes, After that, it will show you how many are labeled low and medium. Thank you. Hello. Now I believe that you've already known what RiskEvader is and what we do. I will now show you one of the glance functions that we have developed. Here is the list of all open tickets that we have, and they are all the requests that there is at the moment. And once you get here, you need to choose which of the change requests you wanted to view. So let's go for the first one. Okay, once you click on it, you'll see an overall view of this report. And then on the bottom right corner, you'll see this Open RiskEvader. And you click on it, and I'll just make it slightly bigger. And after it loads, and it will load for a while, a very long while, and yes, and you can see the risk evaluation. It's labeled as low risk automatically, and you can override it as high risk or medium risk, or you can choose not to evaluate it at all. So yeah, just leave it at low risk at the moment, because yeah, that's what they predicted. So it also has all the weights and values from the reports page as well, and it will show you the top 5 of the 146 features in this project. And yes, that is our glance function. Thank you. Hi, I'm Vincent, and today I will demonstrate our dashboard, and after that, my teammate Heron and Kane will introduce the system to you. So, for starters, this is our dashboard. It is supposed to show you what percentage of risk are labeled as high, medium, and low. It gives us a quick overview of how the risk is on an overall status. I will now show you how the dashboard actually works. As explained just now, the dashboard is used to show important and vital information about the risk that we have. And this is the main page of the dashboard. From here, you can see that at the moment the accuracy is 80% after the machine learning algorithm has trained. The rate of error is 20%, and the amount of data that has been processed is 7.67 gigabytes. And out of the models that we have trained the data for, AdaBoost gives the best performance. This is the model performance chart that shows the performance of the model. And this is the distribution of the level of risk. It is split into low risk, medium risk, and high risk. You can also change the classifiers that you want to train the data with. At the moment, it's set to linear SVM, but you can set it to a decision tree or something else. You can also choose different samplers, scalars, reducers, and you can also select different features. And after that, you just click on Generate. And the distribution of the data will change. And yes. And here is the machine learning top models. And these are the top models that are generated. And now I would like to pass to Heron and Kane, who will now introduce you to the technical overview of our project. Hi, today I'll be sharing with you our technical overview of our product. We will discuss the technologies used for both our front end and back end, as well as some of the reasons why we chose certain technologies over others. In order to understand our product, we'll need to look at the high-level overview of our product. Our product is split into front end and back end. which are both web servers that communicate over HTTP server. The front end and back end uses different technologies and are completely decoupled. They can only communicate over limited HTTP interface. Node.js and Express.js are used as web servers on the front end, and this choice was made because it is the recommended path for creating microservice that interfaces with Atlassian Cloud, and a template project existed with suitable security configurations. This allowed our project to communicate with Atlassian Connect, an API that is necessary to communicate with the Atlassian suite of products. We later extended our front end to use React on top of Express.js. This is a rather uncommon combination, and this choice was made due to a struggle between legacy and modern Atlassian UI, which was based on React. The front end has relatively small database needs, hence SQLite was chosen. The back end uses Python, which is a very reasonable choice, as we need our models to communicate with the front end, and Python has a great support for machine learning and web serving, which fitted our purpose for developing an AI-enabled risk evaluation. Our backend also uses sklearn library for back-end machine learning. We also ran into a problem as our dev machine cannot process a large quantity of data gathered. Therefore, we decided to use MongoDB, which will move the very fast in-memory processing to a slower database processing, which reduced the overall memory cost, hence solving the problem. We also chose MongoDB because we need to be able to migrate very quickly, and MongoDB supports JSON documents and is considered very fast and widely supported. The migration to MongoDB allows us to completely decouple the global state of the data processing and training stages from the Data Explorer by storing and caching every stage into MongoDB. We also store in all data relevant to a particular collection of our project into separate universe. This means that an end user that applies our microservice to their product will only see the data relevant to their project, allowing us to develop something we called Wormhole Server, a hand-rolled MapReduce style web server that accepts Python scripts and data and executes them in multiple processes in parallel. The Wormhole Server is used in machine learning and data processing stages to significantly speed up the task. For our backend machine learning, we use the sklearn library. We leveraged sklearn flexible API in different stages. Our projects allow substitute of each of these options, namely scalar, the sklearn algorithm, the scalar algorithm, the feature selection algorithm, the samplers, the dimension reducer, and classifiers. Our project will allow substitute of each of these options and is even available to end users in the dashboard. This allows us to eliminate any bias and preconceived